Okay. Rules to compute trail now. Remember, trail is also called as last. In some books, it is last. In some books, it is mentioned as trail. Examiner can ask both. Compute lead and trail or lead and last. So don't be confused. Trail is also called as last. Now, to compute trail, suppose that we have a production such as A derives beta AY, where Y is a single non-terminal at the end. That means if the body of the production ends with a non-terminal, that is the case. Otherwise, Y can be epsilon also. Then trail of A consists of A. So here A is a member of trail of A. The second case, if A derives alpha beta. Here we can see that it is a product or concatenation that ends with a non-terminal. In this case also we ends with a non-terminal, but non-terminal can be epsilon. In this case, alpha beta, the concatenation ends with a non-terminal, then trail of B should be added to trail of A. So here trail of A will be A itself. Here trail of A will be equal to trail of B. Two rules. Now let us take these examples again. You have these examples in your hand. Please don't write now. Let us apply these rules, then we can note down. So we will start with F, because F directly we can see that we can compute F, these two values, F. Or we can take up this E, T also, but T, here we have additional rules. So let us begin with F. F, apply rule number 1, beta AY. What is beta and what is A and Y here? We can see that Y can be A, Y can be epsilon. So there is an invisible Y here. Y is here now after this bracket. Now before bracket, what you can see? Before Y, you can see A. So before this invisible Y, you can see a bracket, a closing bracket. So this is trail of A. So trail of F becomes closing bracket. If you are clear, you can note it down. I hope you are clear. No questions. So please note down this. So then we have to take up the next product. Okay. Trail of F. So to see trail of F, we'll see P5. P5 is F derives E. F derives this E, sub-expression E. We'll take rule number 1. A derives beta AY, where the production should end with a single non-terminal. So here, this single non-terminal can be either it will exist or it is epsilon. See here. Here we don't have a Y. Y is epsilon here. It's no problem. So as per the rule, either Y should exist or Y can be epsilon. So here we can see there is no Y. In such case, we'll assume that there is a Y here. We have an invisible Y here. In front of Y, what is there? We have an A. A should be added to trail of A. So here, in front of this invisible Y, we have a closing bracket. So closing bracket will be added to trail of F. Hence, trail of S will be closing bracket. Is it clear?
Yes, sir.
I hope it is clear. Otherwise, you can put on your mic and stop me. So see P6 now. F derives ID. In F derives ID, we can apply rule number 1 or rule number 2. See ID. Here beta AY. We can, as before, there is no Y here. In front of Y, there is an ID. So trail of F become also ID. Let us take a union of these two. We'll get closing bracket and ID as the elements of trail of F. So I hope that finding of trail for F is clear now. And you have noted down. Shall we go to the next slide? We are computing now the trail functions for T. So T derives T into F, it is P3. P3 is like, see, we'll apply rule number 1 here. A derives beta AY. Y, so this production ends with a single non-terminal. We can see that T derives T into F ends with a single non-terminal called as F. So what is in front of F? It is star. Add star to the trail of T. Star trail of T equal to star. It is over. If it is clear, please note down this step. Now let us take P4. In P4, we can see T derives F. I told you that you can apply this or this here. So alpha, beta, it is a concatenation where beta, alpha, beta. So here there is an invisible epsilon here. ID is coming alone. So if ID is coming alone, there is no problem. Trail of B should be added to trail of A. So trail of ID will be ID itself. So ID will come here. If you are applying rule number 2, otherwise you can go for rule number 1. In that case, Y is epsilon here. In front of Y, you have a ID. So ID will become automatically the element of T. So T equal to closing bracket and ID. Take a union of these two trails, you will get the final answer. So that's it. In productions, you may have to apply both the rules to get additional elements. Don't stop with one rule as such. In this example, rule number 1 and 2 should be applied. In certain cases, we need to apply only one rule. Now to compute the trail for E, we'll do as before. A derives beta AY, E derives beta AY, where AY is a single non-terminal. Here T is a single non-terminal. In front of Y we have A, in front of T we have plus. So add plus to the trail of E. So trail of E becomes plus. Let us take E derives T, A derives alpha, beta, then add trail of B to trail of A. In that case, we will see that we will get, when we take up second production, we will get trail of, here it is trail of E. See, when I copied it down, this it was the previous slide was repeated, so please correct this. See, consider P1. We can say we have to consider P1. Yes, lead P1, apply P1 and apply rule number 1. Lead of E is plus. Now consider P2 and apply rule number 2. We will get lead of E as lead of, we are computing trail, trail of E. See, consider P1, trail of E is plus, that we have seen. Now we will apply rule number 2, then we'll take the trail of E. So A derives alpha, beta. Here alpha is not there, but beta is, B is there. So A derives AB, trail of E equal to trail of T. Trail of E equal to trail of T. So T we have done earlier, so we can take a union of these to compute the final answer for trail of E. It is trail of E equal to plus star greater than ID. I hope it is clear.